So, hello everyone. I hope you all have given the contest and have practiced the questions which you couldn't able to solve in the contest. So, I will be discussing the question which is only made by me, okay, and the rest of the question will be taken by Krishna. So, I will be discussing the question number 4 of the contest, okay. So, let us start. I hope you all have attempted this question after the contest. Then that's the point of seeing the video. If you haven't attempted the question yet, then go and try to attempt it again. And if you still can't able to solve it, then come back to video and see the solution. I will be discussing the complete intuition that how would you solve this question in a general contest. Okay, so yeah, so I will be solving this question just like you, like from the basic till how to get into the solution. So yeah, let us start. So the question is others brain teaser one. So let's start. In the first line also I have given you the hint that think more and code less. So yeah, so let's start. So Archit and Manohar are two maths enthusiasts who have organized a strategic game between themselves. Okay, so they are given an array of length n, and they have also defined a variable cost, which is initially equal to alternate sum between the elements and the first element which start as positive. So yeah, first of all, see how the cost is being defined. Here, A1 does not represent the first index of the array. It denotes one based indexing of the array. It's the general notation you will see in the code forces contest also, that A1 does not denotes the second index, means it just denotes that the array starts from the first index and it ends at the nth index. Okay, so here 1 means the first element of the array and a n represent the last element of the array. Okay, so yeah, let's start. That's why you can also see that the last element of the array is represented by n, and in zero based indexing it is not possible that we could access the element at index n, because the array of n size will always have the indexes from 0 to n minus 1. So this part was asked by the most of the student by me in the most, not but some of the student by me in during the contest. I hope that this makes sense. So yeah, so let's see how the cost variable is being defined. First of all, let us take an array. Okay, uh, let's suppose the array is 5, 4, 3, and then 2, and then 1. Then cost is the alternate sum starting from the positive. So first 5 minus 4 plus 3 minus 2 and plus 1. Okay, so the cost, initial cost is equals to 3 of this array. So that's what is the meaning of this line. Okay, after that they have defined a function fa cost. Fa is equals to cost, and they play a game for at most 10 to the power 58 turns, taking turns alternatively with maneuver going first. Okay, so so maneuver is going first in this game. In each term, the current player must perform exactly one of the following operation. So in each term, both the player can only perform the one of the following operation. Okay, I hope this makes sense. How to erase? Yeah. So till here, I hope everything is clear. So now let's go into the later half of the question. How the operations is being defined, and the game. immediately for both the players. It means that in each turn they have the right to end the game immediately, or they can to choose they can choose two indices L and R such that L is less than equals to R less than equals to N. Here you can also see that the array is defined as one based indexing nor a zero based indexing. Okay, and in each operation you can swap the two elements AL and AR. Okay, and one more confusion which I have faced a lot during the contest, that after swapping these two elements cost will again get redefined. Okay, it is but obvious, right, that if we are swapping the two elements, then the cost will get redefined as the configuration of the array will get changed. Suppose the initial array is 5 3 2 1, then 5 minus 3 plus 2 minus 1, so it is equals to 2 and 1 3. Suppose we swap the element 3 and 2, then 5 2 3 and 1. After that 5 minus 2 plus 3 and minus 1, 8 minus 3, so 5. Okay, so this is how the cost variable is also changing. Okay, so now Mirza bhai. After that, additional one more constraint is that after you swap each element, cost of R minus L will get added into the cost variable. Then now see how the cost variable is changing. After each swap, first of all the configuration of the array is changing. So we will again calculate the cost taking the new configuration, and after that we will add the cost of R minus L into the cost variable. So this is the new cost after swapping L and R. So each player can do these operations. Okay. After that, you need to calculate the minimum number of operation that will help between them if they play optimally. What does optimally means? See this line. Maneuver always tries to maximize the FA. The FA is what? Cost variable. Maneuver will always try to maximize the cost variable. Meanwhile, Archit will try to decrement the cost variable. Okay. So optimally means they will always use their brain. Okay. That whether if they perform the operation, the cost variable will get increase or decrease. If the cost variable will get increase, they will, suppose for the Archit case I am talking about, if the cost variable will get increase, then Archit will end the game as he tries to minimize the cost variable. And if the cost variable get decrease, then maneuver will break the game because he tries to maximize the cost variable. Okay, I hope this makes sense. After that, the uh, input format is given, that you are given a test case, and the single integer n is 2 into 10 raised to the power 5 to 1. This is the size of the n, and the array element can go as large as 10 raised to the power 9. Okay, so first of all you also get understand in this video. Okay, that how can we calculate the time complexity in this question. Look, uh in 1 second, our computer can at most perform 10 raised to the power 8 operation. Okay, so in while traversing throughout the n, okay, so n size is given as 2 into 10 raised to the power 5. So if we traverse through the whole array, then we would have to perform 2 into 10 raised to the power 5 operations, which is less than 10 raised to the power 8. So O of n time complexity will get work here. Okay. And suppose we have to, now let's check for n square. How would we calculate about n square? See, 2 into 10 raised to the power 5, then its square. Then it would come out as 4 into 10 raised to the power 8. 4 into 10 raised to the power 10. And at max our computer can perform 10 raised to the power 8 operation in 1 second. So if we think of a n square time complexity solution, it would take almost 200 seconds to work. That is not good. Okay, so we have to think of a solution that runs in big O of n, or at most big O of n log n. If you would take the logarithmic of this and then multiply with n, it would also be fine. So yeah, but I have just explained you the time complexity just for your understanding. In this question we don't even have to use the time complexity of O of n. Okay, it will be solved in a constant time complexity. So yeah, so now let's jump into the intuition part of the problem. How do we get the intuition? चल जा भाई, intuition part, ठीक है. Okay, so in this, two things we have got, that we would be given a cost variable that would be initialized as I have told you earlier, that the alternate sum of the elements starting from 0 indexing to till the n minus 1th indexing. Okay, and in each operation, if the person choose to swap between the elements, then cost of r minus l would get added into its cost variable. Then cost of r minus l would add into its cost variable. Else, if he tries to uh, end the game, then the game will end and the number of operation that have been performed so far will get printed at the end. Okay, so see, first of all maneuver will go, and he will see two things. First of all, he will see the array. Okay, suppose the array is 5, 8, 6, 2, 1. 0 index, first index, second index, third index, and fourth index. So 5 minus 8 plus 6 minus 2 and plus 1. Okay, so this is the initial cost variable. Maneuver has a lot of way to maximize the array. Suppose he swap these two elements. Okay, suppose he thinks to swap these two elements. So then 8 will become as positive and 5 will become as negative. Got it? Suppose he does not think to swap these elements. Okay, suppose he does not want to change the configuration of the array, he can still swap 5 and 1. This will still add up in his answer as the means the positive part of the array. First of all, let me write this is the positive part of the array and this is the negative part of the array. Suppose he swap this and this, still the positive part of the array remains same and the negative part of the array remains same. Still a cost of what? 4 minus 0 will get added into its cost, which will always increase the cost variable. So for any array of size greater than equals to 3, he will always find two indices which will never change the configuration of the array, and it will always add a cost of r minus l r minus l to its answer. Suppose an array of size 3, 1, 2, and 3. If is 1 plus 2, 1 minus 2 plus 3, what is the positive part of the array? 1 comma 3. And what is the negative part of the array? 2. If he swaps 1 and 3, nothing changes in the configuration of the array, because the positive part of the array still remains the same and the negative part of the array still remains the same. Okay, so and it will add a cost of r minus l to its cost variable, which will increase its cost. So till now you have got that. Till now हम लोग समझे that for any array of size greater than equals to 3, maneuver will always want that the game continues. ठीक है. But now let's think about the Archit case. He will think that whatever swap he does, suppose the array is like this 5, 6, 1, 2. Suppose he saw that 5 minus 6 plus 1 minus 2. Suppose he saw that the 5 is contributing a lot in the positive side. So first of all, let me write the positive side and let me write the negative side. He saw that the 5 is contributing a lot in the positive side. Okay, so he will try to swap 5 and 2. Okay, this will add the cost in the array as how much? 0, 1, 2, 3. 3 minus 0. Swap, he did the swap part 1 comma 2 and 6 comma 5, and it would add a cost of 3 minus 0 in the array. And he decided not to end the game. So after Archit move, maneuver will come, and he will again reverse the array. Reverse the swapping choice of the Archit. Reverse the swapping choice of the Archit. Okay. He will again swap this. He will again reverse the swapping choice of the Archit. So the configuration will remain same as it was before Archit, and the cost of 3, and in this case cost of 3 will get added into the answer. So now Archit will think that if the size of the array is greater than or equal to 3, it will be optimal for him to end the game irrespective of the configuration of the array. Okay, because maneuver will always reverse the Archit's choice, and it will add a cost of r minus l in the answer. Why I am always saying for n why I am always saying for n greater than equals to 3. Suppose we take an array of n is equals to 2. Sorry, n is what I am doing by n is equals to, where is the button? N is equals to 2. Okay, so for n is equals to 2, positive part, negative part. So positive part is what? 1000, and negative part is what? 100. So maneuver here can't do any swap operation. Why he can't do any swap operation? Because if he does the swap operation, then the configuration of the positive part and the negative part will get changed now, because there is only one element in the positive part and there is only one element in the negative part. Okay, so for n is equals to 2, maneuver will have to think that whether swapping is a good choice or a bad choice for him. When swapping would be a good choice for him, suppose the array is 1 comma 2. So what is the initial cost of the array? 1 minus 2, so it is minus 1. Okay, so if he swaps, it will be 2 comma 1. So 2 minus 1 plus 1 plus additional r minus l 1. Okay, if this is the initial configuration of the array, he will swap it. Okay, he will swap it and make the array like this. And suppose the initial configuration of the array is 2 comma 1, then if he swaps the array, then the configuration will become 1 comma 2. Then 1 minus 2 plus, due to swapping, a cost of 1 minus 0 will get add. So minus 1 plus 1 is equals to 0. So this would be the cost that will get to Archit, and the initial cost was 2 minus 1 is equals to 1. Obviously this cost is better than this cost, so in this case he would not swap and will end the game. Okay, so now let's write the pseudocode of this problem. Okay, if we have discussed earlier, if n is greater than equals to 3, if n is greater than equals to 3, what would be the answer? Cout 2 handle. Okay, if the size of the array, as we have discussed here, if the size of the array is greater than equals to 3, then it is optimal for the Archit to end the game immediately, because maneuver will always reverse the choice of the Archit and he will continue the game for so long. And suppose if n is equals to 2. Okay, if n is equals to 2, so now think, n for n is equals to, suppose the array is 5 comma 5, here maneuver will definitely swap. So if a of 0 is greater than equals to a of 1, answer will be Cout 2 and then else Cout 1 handle. Okay, if n is equals to 1, then the answer would be, here you must apply else if and else if Cout 1, because if the array size is 1, no one can do any swap operation, so the answer means there is no point of even talking about this. And okay, so yeah, this is the entire code. Only this was the code of the problem. I hope you all get the intuition part and how to solve this type of problem easily. During my explanation it might look complicated, but after the understanding, if you will again see the problem, it is quite straightforward. Typically 900 rated, you can say, in code forces. So yeah, thank you.